Hello everyone, welcome back to my channel, and today we'll continue with our 100 days of DevOps. Today is day 9 and we are continuing with our networking concept. We started fundamentals of understanding networking. We started yesterday, and yesterday we covered IP addresses, we covered subnets, we covered CIDR, which is CIDR, and we covered ports. If you've not seen that video, it's very advisable for you to see that video first before you come to this particular session on this particular video. So I advise that you check out that video. The video is for day 8, and then you can then come back to this particular one to gain or to improve on what you have studied or you've learned in the video before. So today we are going to be talking about OSI model. Today is basically just dedicated to understanding OSI model and TCP/IP. Like I said from the onset, we are in the session of understanding networking, and I said we are going to use the first 2 days to understand concepts before we go into the terminal and start doing stuff. So I really want to take my time to explain 1 or 2 things so that when we see things happening, we understand how they work under the hood. So we don't just see it on a surface level and don't know how it works, because when you understand all those things, it's very easier for you to interact with all these components when you get to the terminal or when you are in a production environment. So without wasting more time, I'm going to start with OSI model. So what is OSI model? Now imagine you go to your browser, your computer or your laptop browser, and you type facebook.com, www.facebook.com. So in a fraction of seconds, you get the Facebook homepage. So have you ever thought to wonder what really happens within the time that you type that facebook.com and the time that the facebook.com homepage is displayed to you? Have you ever wondered what processes happens or what takes place for this to actually come into play? So this is where the OSI model comes in. So when you type facebook.com, it goes to this Facebook server, and then it sends a request to it, and then the server sends a request back. So understanding OSI model will help you to understand the different components or the different parts or the different activities that have taken place before your request for Facebook to get to facebook.com is granted. So basically this is what we're going to be studying here. But before that, there's something I want to so this is the OSI model, layers of the OSI model. Before that, there's something I would want to literally touch on. So for when you go to your browser and you type www.facebook.com, before even the process of the OSI process, before it even starts, there are 2 things that are very important, and which is a prerequisite. So these ones, they need to even happen in the first place before the whole OSI thing can even start. There are 2 things that need to happen. The first thing is DNS resolution. And the second is TCP handshake. So I'm going to start with the first one. The first one is DNS resolution. Basically, DNS means domain naming service. So what happens? It's what yesterday I talked about IP addresses. So but when you want to go to Facebook, you don't type Facebook's IP address. You type www.facebook.com, and that's because the name facebook.com has been mapped to Facebook IP address. So, and this is done by the DNS. So DNS is basically what maps an IP address to a name. So the name facebook.com has been mapped to the Facebook IP address. So that's why when you type facebook.com, it's actually a representation of an IP address. So the DNS resolution, what happens is that when you type facebook.com, your system looks into your local browser or your local how do I call it now? Your local file system to check if this particular name is available on system. It's just like let's say just like a table. Let's say it's like a table where all the IP addresses and all the names are kept. So it goes to that particular table and checks, is facebook.com on this my table? It does that locally first. It says, is facebook.com on the list of things that I have on this table? If it says yes, then that's good. It goes to the second stage, which is the TCP handshake. If it says no, it goes out externally to your internet service provider, because your ISPs, that's your internet service providers, they also have their DNS servers where they have all these things there. So it now goes to your ISPs, and then your ISP will now check, okay, is there any name called facebook.com? So when it checks and it sees it, then fine, it goes to the next stage. So if you type a website, let's say you type tech.sam.com, and that name does not exist, or it's not mapped to an IP address, you would not get anything in return, because first of all, it has failed the first test. It was not able to resolve that name to a particular IP address. So that's the first thing that I need you to understand. So once you type in a name like a website, the first thing that happens is the name resolution. So if that name does not exist, you get an error. So but if the name exists, then you go to the second stage, which is TCP handshake. So basically what is TCP handshake is just, let me do this. Let me just use some shapes. So let's say this is your computer, and then this is another shape. This is your browser. So remember, now we have gone past the stage of the DNS resolution. So now we are in the TCP handshake. So what actually happens? Your computer sends an acknowledgement request. It's called sync. It's SNYK. So it sends an acknowledgement request. It's just saying, it's like just a way of saying hello. So when it sends that request, when it sends a request to the server, then the server sends another acknowledgement request to your system. So it's also called sync acknowledgement. The first one is the sync, the second is the sync acknowledgement, and then after that, your computer sends another one again to it. So this is what we call the three-way handshake. The three-way handshake, your computer sends a request to the server. That's just to communicate it that, okay, are you available? Or hello, I'm trying to talk to you. Are you available to listen to me? So the server sends a request back and says, oh, hi, I can hear you. I'm available to listen to you. Then your computer now sends another request back and say, oh, cool. Then the whole process can start. They might be wondering, why is it three-way? Why can't it just be your computer sends a request and then the server sends an acknowledgement? Well, that's a different concept on its own, and I can't really start buttressing on all of that, but you can, something that if you're interested in, you can research on it to gain more understanding. So but I know that there are three-way handshake, there's two-way handshake, and then there's four-way handshake, but the most common or the most popular one is the three-way handshake. Yes. So it's a three-way handshake. And basically, yes, those are the two things that needs to be fulfilled. Those are the two criteria that needs to be fulfilled before anything can even start happening. Before anything can even start happening between your computer and the Facebook server, DNS resolution has to be done, and TCP handshake has to be done. Then once these two criteria are fulfilled, then we can start with that. Then the whole process of the OSI model and everything, that's when it begins. I just wanted to drive this home so that we have this at the back of our mind. So let's now look at the OSI model. The OSI model is divided into 7 layers, as you can see on my screen. The OSI model is divided into 7 layers. We have the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. So I'm going to take my time to take it step by step. So now I'll start from layer 7, because when you type in that address, that's the name, that's the website name, your system actually starts from layer 7 down to layer 1. So it starts from 7 to 1. Then the server, when the server starts from 1 to 7, the request is made from layer 7 to layer 1, while the response is made from layer 1 to down to up to layer 7 rather. So basically, that's just also what I need to mention. That's what you also have to have in mind. So now you type in that www.facebook.com. So what happens? What happens is that once you type in that facebook.com, it's kind of it prepares like a session. What happens in the layer 7 is that it prepares a session. It initiates a request to the server. And most times, if you notice, when you want to type in www.facebook.com, it's something like HTTP. So that HTTP is a request type. Is a request type. So there can be HTTP. You can even have FTP. So depending on what you want. So a HTTP or an HTTP request is initiated by your browser to that particular server, that's to the Facebook server. So basically in layer 7, what happens is, which is the application layer, the request is initiated, and this is done on your browser. So once the request is initiated, what happens? Now, basically all the things that we see, all the contents we see online and everything, they are basically just data. They're just basically data that is displayed to us in different form. So once your HTTP request has been made in layer 7, what happens is the data is actually encrypted. So it's encrypted and it's formatted in a way, because now there are different routes. Or let's say, for example, if you are going to one place to another place, you need to make sure that everything is secured, because if your data is not encrypted, there can be security breaches. You can be open to vulnerability, and also basically that's why this layer is very, very important, which is called the presentation layer. So this is where the data encryption takes place, as whatever data you're trying to send, or whatever data you're requesting, this is where encryption of that data, that's the request you've made in layer 7, this is where the encryption takes place. So, and that is basically what happens in layer 6. So once your HTTP request has been initiated, and then your data has been encrypted and formatted, what happens? Your browser then creates a session. So it creates a session for that particular request. And I want to I'll take some time to explain this, what I mean by session. So in this layer, in this session layer, I know sometimes when you go to your browser and you type facebook.com, and you're done checking what you want to check on Facebook, and you close the browser. You didn't log out, you close the browser. By the time you go back to that browser and you type facebook.com, it's not going to ask you to log in again. It doesn't authenticate you again. And why do you think that comes into play? This is because of this session layer. So this session layer is what enables you to not authenticate every time you try to access the website after authenticating once without logging out. So if you go to facebook.com, you sign in, and then you close your browser. You didn't log out. You just close the browser, and maybe you're done with whatever you're doing. When you now go back to that same website, and you type facebook.com, it doesn't take you to the sign-in page again. It just takes you to the normal browser interface. That's because the moment you signed in for the first time, a session was created for you. And this thing, that's where the concept of cookies, right? But if you log into if you go to some website, you see something like accept cookies, you accept cache and everything. So if you notice, if you just want to test this, go to your browser and then clear your cache and then clear your cookies, and then come back. Maybe go to facebook.com, authenticate, log in, close the browser, try and go to facebook.com again. You will see that it won't ask you to authenticate yourself again. It takes you to the Facebook platform. But now go to your browser settings and then you clear cookies and clear cache. Then try and log in and then go to facebook.com again. You will see that it will ask you for your username and your password again because you've cleared the session that you had. So that's the importance of this session. It helps you. It's the same goes for your banking application. So it's what helps you to access that platform without having to authenticate all the time. So, and then most of your information are stored in the cache and then the cookies and all that. So you can cache, cookies and everything is what you can buy. Maybe in your leisure time, you can watch videos on to gain more understanding. So, but basically in the session layer, once your request has been made, most times HTTP request, once it has been initiated and data has been encrypted, a session is open for you. And the only way for you to get rid of that session is to go to your browser settings and you clear your cache, you clear your cache, you clear your cookies. So that's basically what happens in the session layer. And one thing is that these first three layers, the layer 6, the layer 7, the layer 6, and the layer 5, it happens on your browser, not over the internet or not over the web or anything. These first three layers happens on your browser. It is initiated basically on your browser. So if you're using Microsoft Edge, if you're using Firefox, if you're using Chrome, and you access a website or you access a platform, the first three layers of the OSI model is handled by that particular browser that you're using. So now, after the session has been created, we go to layer 4. So in layer 4, this is where segmentation comes into play. This is where the data is split into parts. It's split into parts, and then the protocol is identified. The protocol is basically your protocol is like this stage is the transport layer. So basically it's movement of data. Now for that data, it's a big chunk of data. So what we do is that, or what is done is that the data is split into segments and then transmitted. So and there are two protocols that is basically two predominant protocols that are used in terms of data transmission, which is the TCP and the UDP. So there's difference between the TCP and the UDP. In terms of, I'm just going to give a quick comparison. TCP is more secure. Like if you're making an HTTP request now, most times the protocol that will be used for transportation of data is TCP. But if you're using, if you're trying to reach out to maybe like a DNS server or something, you can use UDP, something that is really not really like secure like that. But now the TCP is a more secure protocol than UDP in the sense that those data will travel according to how according to how they have been labeled, because each data is labeled. So it's going to travel according to how they have been labeled. Data that is labeled number 1 would not go. Data that is labeled number 2 will not go after number 1 has gone. So it's from label 1 to label 2 to label 3 to label 4 and down, basically. So, but because of that, because everything has to follow that order, it is slower. It is slower than, I'm not saying your browser will load slow or anything, but in terms of speed, compared to UDP, TCP is slower in terms of speed. You understand? So TCP prioritizes data safety, data security. That's what TCP prioritizes, and making sure that your data gets to your destination the same way it has been sent. However, UDP, in terms of speed, UDP is faster. Like it's very, very, very fast. If you need something done really quick and everything, you can use the UDP protocol. However, data does not data is not being transferred, in an orderly manner. You can see data 2 can be ahead, and then data 1 can be in the back, and it's just going to travel anyhow, like it's just going to go anyhow, but it's going to be fast. So if you're looking for your data security and all that, it's better for you to use TCP. So these are the two protocols. So you can also read more on TCP, UDP, understand their differences and how to use them, when to use them, and all that. So now that the protocol has been identified, this is the transport layer basically. So at this point, it's no longer just on your system. It has moved out of your system. And then where does it move to? The data is now, once after it has been transported, now we said the data is being transported. So where is it going to? So the data is received by the router, which takes us to layer 3. Data is received by the router, and then this is where your paths, that's the path to which information is going to travel, is defined. Now, what do I mean by that? When you make a request, the internet looks for the shortest possible route to get your request attended to. Look for the shortest possible route, and in that way, before your request gets to a particular place, it must have hit different routers at different locations. So it is this layer that all this is actually defined. And by the time you keep hitting different routers in different locations, there's a possibility that things might get mixed up. So what happens in this location? The router includes a source IP address and destination IP address. So you know where your request is coming from. You know where your request is going to. So no matter the different stages, or no matter the different more routers that your request hits on the way, it's still going to go to where it has been assigned to go, because it has added the source IP address and the destination IP address. And once this has been added, now it becomes packets. So basically, you can say the data in layer 3 are transmitted, or they are moved in packets. They become packets. Now, these packets, they have information of how your data is going to travel, and all the information, everywhere that which paths it takes, just like I explained, how it is going to get to the destination, and your router defines all this. So this is what happens in layer 3. Your router adds, and that's why it's called the network layer. Your router adds the source IP address, your router adds the destination IP address, and then your router defines which paths it's going to take for that data. Remember, we're coming from layer 7. Remember, we're coming from where the request has been, initiated, and when data has been encrypted, transported down and all that. So now data is now moving. So, and then all these things are added to the data, and then it becomes packets. So what now happens afterwards? Every router basically is connected to a switch, or maybe your cable. So it's connected to a switch, and then either switch or Ethernet port. Yes, so the router is either connected to a switch or Ethernet port. So now, what happens in this particular layer, which is the data link layer? The data link layer, it can't work with frames. So what happens is that it can't work with, what do you call it, with packets. So what happens is that the packet is converted to frames for easy understanding. In this layer, packets are not really understood. So it's converted into frames, and then your MAC is also included. The MAC address shows it gives you more information about the components of where you're going to. So this is apart from the IP address, its destination address, the source IP address, the MAC address is also included in this particular stage, and then data is transformed from packets to frames. So basically, this is what happens in this. So remember, now we are on the network layer. Now we've gotten to the switch or the Ethernet port layer. Then after that, once all this has been, defined, it moves to the last layer. So now your router, your switch, and all that, they are connected to something called optical cable. And then the language that the optical cable understands is electronic signals. So at this point, everything, it has now moved from, if first it was packets in layer 3, then it moved to frames, and then now it has moved to electronic signals, because now it is connected to the optical cable, and it is these optical cables that transmit the information down to your server. So and then your server receives this response. So this is what we call the physical layer, which is layer 1. So your information has finally gotten to your server. What now happens? The server receives the information, processes the information, and then transports it back. So when it is going back, it goes back from layer 1 to layer 7. It starts from the data being an electronic signal, and then data is transformed to frames, which is layer 2, and then the frames are then transformed to packets, which is layer 3, and then your transport protocol is defined again in layer 4, and then it goes up to that session that has been created, which is layer 5. It also creates a session. Then layer 6 is where the decryption takes place, and then layer 7 you get the response bar. So basically here, when you make when you go to your browser and then you type, this is actually what happens. It happens in a split second. Like before, once you type it, depending on the speed of your internet connection. So once you type an IP address and then you get a response within split second, this is actually what happens. Everything happens in milliseconds, but this is actually what happens under the hood. So a brief recap. Once you go to your website, once you go to your browser and you type a website, the first thing that happens is that the browser initiates. Okay, the first thing that happens is that DNS resolution takes place. And after that, the TCP handshake takes place. Then the 7 layers of the OSI model takes place. Your browser initiates an HTTP request. After that, your request is encrypted. After your encryption takes place, a session is opened, and after that, your data is transmitted using transmission protocol, and then your data moves to the network layer, which becomes packets, and then it defines the routes through which your data is going to take to get to the destination. And then once that is done, and your router your data hits the layer 2, which is the switch or the Ethernet port, it becomes frames, because that is what is understood. That's the format of data that is understood at that level. Then the frames are then transformed into electronic signals, which is the physical layer, and then it's interpreted, or it is received by the Facebook server. And then once your request has been received and has been processed, the whole thing starts again from 1 down to 7. So like I said in the beginning, it starts from 7 to 1. That's where request is made, and then request is now responded to from 1 to 7. So this is an overview of how data is being transferred or data is being transmitted between your browser and the server. Whenever you open your browser now and you type a particular website, have it at the back of your mind that this is actually what happens under the hood. This is actually what happens under the hood. So with this knowledge, you're able to, know how you want to, when it comes to troubleshooting, when there's actually an issue, you're able to know how to address this. So, and I think for DevOps engineers, I'm not exactly too sure. I think most DevOps engineers work in layer 3, I think layer 3, layer 5, and layer 7. I'm not exactly sure, but I know that DevOps engineers work predominantly in 3 layers out of this whole 7 layers. So that's that about OSI model. I don't know if you have any questions. If you have any questions or you have any clarifications, you can feel free to drop your questions in the comment section. I would definitely do well to answer them and then to explain things better so that you get the best out of everything that I say, out of every word that comes out of my mouth. So now I said we're not just going to talk about OSI, we're going to talk about TCP IP. So now, what's the difference between OSI model and TCP IP? So the OSI model is actually the older model. So it's like that's like the framework for everything. However, the TCP IP is the newer model. So it's basically the same thing, but there has been some abstractions, there has been some merging and all that. Remember I said something. I said the first 3 layers of your OSI model, which is the layer 6, the layer 7, the layer 6, the layer 5, they are all handled by your browser. So what the TCP/IP model did was that it grouped these 3 layers into one layer. So it becomes application layer. So your application layer, your presentation layer, your session layer is now grouped into one, which is called the application layer. So and then your transport layer remains the same. Your internet layer kind of remains the same. That's your just the naming convention. One is network layer, one is internet layer. So basically, it's still the same layer 3. Then your data link layer and physical layer are now grouped into one. So basically, it's the same thing, but now there has been some grouping. So that's the difference between the TCP IP model and the OSI model. It's very, very okay for you to understand the OSI model so that you'll be able to get more understanding of the TCP IP model, because yeah, I know that the TCP IP model is the newer model. That's the new model that is being adopted now. But since there have been some abstractions, it won't be okay for you to just say, okay, you want to learn the application, you want to understand the application layer as a whole, when the application layer itself is a breakdown or is a merging together of 3 different layers. So if you don't understand the OSI model very well, then you might struggle to understand, or you might not fully understand the TCP IP model. So basically, it's all the same thing, but now everything is, so some components or some parts are now mixed together. So basically now, when you go to your browser and then you now type a website, the application layer is what happens first. Then from application layer, it moves to the transport layer, moves to the internet layer, and then moves to the network access layer, then gets to the receiving server. Then the receiving server sends a response back through the network layer to the internet layer, transport layer, and application layer. So that's basically the difference between the OSI model and the TCP/IP model. I hope I've been able to quickly do justice to this. So a recap of what we've done in the past 2 days. We've understood some basic networking concepts. We are going to keep unraveling things as we go on, but I just wanted to lay this foundation. So if you understand the concept of IP addresses, if you understand the concept of subnets, if you understand the concept of CIDR, you understand what ports are, and then in the grand scheme, you understand what OSI model is, in which the things or processes that happens before your request is being responded to. Now we've also even touched on DNS. Yes, we're going to still have a session on DNS where I'm going to explain. That's going to be more practical, but now you know that DNS is responsible for naming of your IP addresses, basically. So that's facebook.com that you see that you type on your website and it goes, is actually a name that has been mapped to an IP address. So you also understand what the TCP handshake is, which is 3-way handshake. And I said you can also research or read more on the 2-way handshake and the 4-way handshake. And then we also established that the most common type, or the most predominant type, is the 3-way handshake. And then we now wrapped everything together, understand how everything works under the hood. So with this knowledge, I feel that we are well equipped to now start doing some practical or start doing some hands-on things. So the more we do the hands-on things, the more I keep referring back to this, and the more I keep trying to put the pieces together. So I would implore that if you've not actually been following this journey from the onset, it's going to be in your best interest for you to start from the very beginning. That start from day one, the very beginning, and then you take it down to today. This is day 9. So we've covered a whole lot. We've come a long way. We've covered Linux, and then now we're starting with networking, and then we still have a very, very long way and very, very interesting journey ahead of us. So, and lastly, if you know anybody that wants to actually go into tech, know anybody that wants to actually go into DevOps, go into cloud computing, or even system administration, you can share this channel or share this playlist with them so they can watch, maybe get a little understanding, reach out to me whenever or wherever they feel confused. And don't forget to subscribe to my channel, and most importantly, turn on the notification bell so that when I upload more content like tomorrow's content, you can quickly get it, you can watch it, and then you can also add to the knowledge that we've already been building from day one. So that will be all from me for now. I would see you again tomorrow. Cheers.